Okay, so now we're going to be talking about a frequency distribution. Oh, excuse me. I haven't had a cup of coffee yesterday. I can't stop yawning. So, a frequency distribution is a table displaying the number of values that fall within a specific category. So, that's the biggest thing. As we saw in past examples, um, oh God, anyway, so, um, a frequency distribution. So, in two videos ago, we just started talking about tables, but those tables were representing just individual values. In this case, when we talk about a frequency distribution, we talk about a range of values over a course amount of time. So the best way to think about a frequency distribution is like age, for example. So think about, when you were a kid, possibly in like younger sports teams, in the beginning, it's kind of just a bunch of kids of different age. Maybe you have them, 3 to 5, 6 to 8, and now we're seeing how frequent do these different data values fall into these range of specific categories. So again, age is the best way to kind of think about it sometimes, because just different age categories, or even like think of voting for example, the way they could separate voting is from 18 to 23, 24 to 29, so on and so forth. So it's just instead of looking at one age, so just how many 18-year-olds, how many 19-year-olds, we're looking at just a range that fall into a specific category. So when the categories represent a range of numerical values, we call the categories class intervals. So let's go straight into an example to kind of better understand what we're talking about. So the ages of individuals arrested on a certain day in Texas are listed. So notice these are the class intervals. And this is what we're talking about. We're trying to see from these data values how many are falling into this range of values. So how many are between 18 to 23. One thing to notice between class intervals, you'll never see the same numbers represent because that wouldn't be represented twice. So notice 18 to 23, 23 is the cutoff, then we're picking back up at 24. We're not going from 23 to 29 because again, that would imply that people would fall into multiple categories. So wherever you cut off, the next class interval will pick up and so on and so forth. Okay, let's get started. So now we're just counting up how many fall into 18 to 23. Well, we have 1, 2, 3, 4, 5, 6, 7. Is that just it? 7. So first we're doing a tally. So by tally mark. So 1, 2, 3, 4, 5, 1, 2. So the frequency is 7. So we're seeing again how frequent these values fall into each category. So we have 18 to 20. Yeah, let me count that. 1, 1, 2, 3, 4, 5, 6, 7. Yeah. I don't know why I thought there was more. And then now we pick up from 24 to 29. So we have a 26-year-old, a 24-year-old, a 28, a 25, to 29. So that's including 29 and another 26-year-old. So again, notice everyone's going into just one category. That's why you want to make sure you're wherever you're cutting off in the next category, you're picking back up because you don't want, it wouldn't make sense to have someone in two categories because they're just falling into one range. So in this case, we have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. Ooh, 5, 6. And that is number 6. Okay. Ooh, doo, 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 doo. Then we have 30 to 35. So we have 35, 32, 30. And I believe that's all. So 3. 36 to 41. We have a 39-year-old. That's 1. Oh, there was one more. There was a 34-year-old for the last one. This should be 4. See, that's why sometimes you want to double check these things because it's super easy to kind of just fly over someone. So there was 4 30 to 35. Let me double check. Yep. And now we want 36 to 41. There's a 40-year-old, there was a 39-year-old. And I believe that is everything. So we have 2. And last but not least, from 42 to 47, we have 1 46-year-old, so 1. So again, notice it's not just looking at one data value. We're looking at a whole group of different ages. Okay. And then we can go ahead and answer questions. So that's always the big thing. Again, once you kind of organize this data, we want questions to be answered because again, that's the whole point of things. So which class age group has the most value? So now we go back to our frequency table and we start reflecting back to answer these questions. So in this case, 18 to 23, since they had 7. So 18, 23. How many values are represented in the table? So what that means is we want to add up everything. In total, how many values do we see? So we have 7 plus 6, which is 13, plus 4, which is 17, plus 2, which is 19, plus 1. So we have 20. So in total, there are 20. And then it says, what percent of people arrested are in the group 42 to 47? So in this case, remember when it comes to percents, one way we can get to a percent is by a fraction and then performing long division. So what we want to figure out is the parts out of a whole. So we know in total, we have 20 people. And how many of those 20 people are in the category from 42 to 47? 1. Once we have this fraction, remember, so this is something you want to remember for the final, since this could be something tested on. From a fraction, we can go to percents with long division. So if you were to long divide this, you would get 0.05. And then from there, if we remember, once we get to a decimal, the decimal was the in-between step. That's why we had to do long division. Then from a decimal to a percent, we move the decimal over 2 spots to the right. So we get 5%. And then lastly, we have a histogram. And a histogram, so we talked about bar graphs, but a histogram is just specific for frequency distributions. So it's just these range of values. So remember in the last video when we talked about bar graphs, it was just like different ice creams. So we looked at individually different ice creams. But in this case, a histogram is specific for frequency distributions. So a range of values. Okay, and we got one more video.
Found this on the web.
No, Apple Watch.